if we heat the gas to the higher temperature, the peak of the graph will shift to the right, since that the average molecular weight will increase. As the graph shifts to the right, the height of the graph has increased in order to maintain the same area under the curve. Similarly, as the gas is cooled to the lower temperature, the peak of the graph will shift to the left. As the graph shifts to the left, the height of the graph has to increase in order to maintain the same area under the curve. This can be seen in the curve, which represents the same gas with a constant amount of molecules at a different temperature, which is as the gas gets cooled, the graph becomes taller and more narrow. Similarly, as the gas gets hotter, the graph becomes shorter and wider. This is required for the area under the curve, which is the total number of molecules to stay constant. If molecules enter the samples, the total area under the curve will increase. Similarly, if the molecule will leave the samples, then the total area under the curve will decrease. The gas of diatomic nitrogen is in a sealed container. The sealed container is placed in an ice bath and reach a lower equilibrium temperature with the ice bath. So what happens to the following quantities as the gas cools? So the answer is the graph of the number of molecules versus the speed will become more narrow. From the figure, state the reason why curve 1 changed to the curve 2. So you can see that the height of the curve is decreased from 1 to 2, indicating that some of the gas molecules are allowed to leave the samples, and then the curve is shift from the right to the left, indicating that the remaining gas sample is cooled in a sealed container. Gas diffusion and effusion. How do smell travel to your nose? Smell travels through the air by a process which is called as a diffusion, which is air particles and the other particles within the air move freely in all directions. They are constantly moving and eventually they spread out through the air around our nose. According to the kinetic molecular theory, gas particles are in a constant state of motion, moving at a random speed and in many different directions. Because of their kinetic energy at temperatures above absolute zero, all particles undergo diffusion. Diffusion is referred to the process of particles moving from an area of high concentration to one of the low concentrations, which is the rate of this movement is a function of temperature, viscosity and the mediums and the size or mass of the particles. Diffusion results in a gradual mixing of materials and eventually it is formed a homogeneous mixture. And a process involving a movement of the gas species similar to a diffusion is called as a diffusion, which is the escape of gas molecule through a tiny hole such as a pinhole in a balloon into a vacuum. Although diffusion and effusion rates both depends on the molar mass of the gas involved, their rates are not equal. However, the ratio of their rates are the same. Thomas Graham studied the effusion and diffusion of gas. Diffusion is the mixing of a gas through each other. For example, gas 1 and gas 2 is spreading throughout the container until evenly distributed, while effusion is the process whereby molecules of the gas escape from its container through a tiny holes. The kinetic molecular theory can be used to explain the result Graham obtained when he studied the diffusion and effusion of gas. The key to this explanation is the last postulate of the kinetic theory, which assumes that the temperature of a system is proportional to the average kinetic energy of its particles and nothing else. In other words, the temperature of a system increases if and only if there is an increase in the average kinetic energy of its particles. For example, two gases such as hydrogen and oxygen at the same temperatures must have the same average kinetic energy. Graham's law states that the rate of effusion and diffusion of gas at the same temperature and pressure is dependent on the size of the molecules. Means that the gas that have a lower molar mass effuse and diffuse at a faster rate than the gas that have a higher molar mass. In the same conditions of temperature and pressure, the molar mass is proportional to the mass density. Therefore, the rate of diffusion of different gases are inversely proportional to the square roots of their mass densities. Diffusion is the movement of a substance from an area of high concentrations to an area of low concentrations. Diffusion happens in liquids and gas because their particles move randomly from place to place. The concept of diffusion is widely used in many fields, including physics, chemistry, biology, and finance. Diffusion is very important in the body for the movement of substance. For example, the movement of oxygen from the air into the blood and carbon dioxide out of the blood into the air in the lungs, or the movement of the glucose from the blood to the cell. In the diffusion of ammonia and hydrochloric acid, the ring usually forms nearer to the hydrochloric acid end of the tube because the hydrogen chloride diffuses more slowly than the ammonia. This is because the hydrogen chloride has almost twice the molecular weight of ammonia, and the rate of diffusion is inversely proportional to the square root of the molecular mass of the gas, so that the root mean square speed of the light gas is greater than the heavier gas, which is the lighter gas will diffuse more quickly than the heavier gas. Diffusion is random motions with the directions. Diffusion refers to the transport of metals through concentrations gradients from the regions of the higher concentrations to the lower concentrations. For example, the diffusion of the tea from the tea bags into the water. Molecules are in constant movement and collide with each other. The collisions can cause the molecule to move into the random directions, and over time, more molecules will be propelled into the less concentrated area. Thus, the net movement of the molecule is always from the highly packed areas to the less tightly packed areas. From the figure, when the stopcock is opened, the random motion causes each gas to diffuse into the other containers. And after the diffusion is complete, the individual molecules of both kinds of the gas will continue to pass between the flasks in the both directions, so that the concentration of the both gas, which is nitrogen and oxygen, is similar in both flasks. Graham's law of diffusion. Kinetic molecular theory assumes that the molecules of gas are in rapid random motions, and their average velocities are proportional to the absolute temperature. It also assumes that at the same temperature, the average kinetic energy of the molecules of different gases are equal. Graham's law of diffusion is based on the above assumptions of kinetic molecular theory. We usually cannot see the gas, so we need a way to detect their movement indirectly. The relative rates of diffusion of ammonia to the hydrogen chloride can be observed in a simple experiment, which is the cotton balls are soaked in the solutions of ammonia and hydrogen chloride and attached to two different rubber stoppers, and these are simultaneously plugged into either end of a long glass tubes, and the vapor of each travel down the tube at the different rates. Where the vapor meets, they react to form the ammonium chloride, which is a white solid that appears in the glass tube as a ring. For the figure 1, which is both gases are moved at the same speed and meet exactly in the middle, while for choice 2, which is the lighter gas, will move faster and meet closer to the heavier gas, which is the ammonia is the lighter if compared to the hydrochloric acid. In what part of the tubes will be the ammonium chloride first be observed? The answer is the ammonium chloride first be observed at the right, which is near to the hydrogen chloride bottles. It is because hydrogen chloride diffuses slower than the ammonia because the mass of hydrogen chloride is more than the mass of ammonia. Since the rate of diffusion is inverse to the mass, therefore the ammonia will travel more distance than the hydrogen chloride at the same time intervals, and the two gases will first meets near to the hydrogen chloride's end. And secondly, if the distance between the two ends of the tube is equal to 100 cm, how many cm from the left end of the tube will be the ammonium chloride first formed? Okay, now according to the Graham's law, the rate of diffusion of ammonia to the rate of diffusion of hydrogen chloride is equal to the square root of the molar mass of the hydrogen chloride over the molar mass of the ammonia. So from the calculations, the rate of diffusion of the ammonia to the rate of diffusion of hydrogen chloride is equal to 1.463. Therefore, the distance is equal to 60 cm from ammonia ends, and at the distance equal to 40 cm from the hydrogen chloride end, which is the ammonium chloride, will first appear. A process involving movement of gas species similar to the diffusion is called as effusion. Effusion is the escape of the gas molecule through a tiny hole, such as a pinhole in the balloons, into a vacuum. Although the diffusion and effusion rates both depends on the molar mass of the gas involved, their rates are not equal. However, the ratio of their rates are the same. In physics and chemistry, effusion is the process in which a gas escapes from the container through a hole of diameter which is considerably smaller than the mean free path of the molecules.